This is chapter 5, project structure of Rustaceans. It covers quite a lot of topics, starts with covering features, what they are in a crate, how you use them, what their kind of aim is, using workspaces, which is how you kind of collect things together beyond just a crate. The various features you have in a cargo.toml, there's a lot of flags in there that you can use. So this just covers a few crucial ones that you might not know about or might not have thought about too much. And then talking about versioning, how you version things in Rust typically, and some best practices or opinions on how you might manage that. The first section is on features. So features can be enabled on a dependency using the features key. I'm sure many of you will have used this, whether deliberately or by accident, maybe from copying code online. The idea is that a crate doesn't have to ship with everything that it has possible. It can ship with just a minimal set of features, and then you can opt in to additional ones. So in this case, we're pulling in serde, but we're also pulling in the derive feature of serde, which allows us to automatically derive serde implementations. So these features are used to conditionally include optional components, enable optional dependencies, and augment the behavior of crate. The reason we do this is to reduce build times and file sizes, but also sometimes you do want things to behave differently that might have performance implications, but maybe you need it. So for example, in serde.json, you can choose to preserve order for maps. So by default, it won't be necessarily in a particular order. The keys for JSON, usually most implementations don't preserve the order, but you can preserve the order. And if you do, then that's a behavior change that you could enable with a feature. You do have to be careful with extending behavior like that, because some kind of changes in behavior could be considered semantic versioning breaks. So they might be significant differences. So you want the behavior to match what it is with and without the feature toggle. You can also enable no-std support. So if you're working in an embedded environment, you might not want to have the whole standard library, but it's a lot more straightforward to have it enabled, and then you can cut out those components if someone doesn't want them. You can also re-export dependency features, so that way, if there's certain dependencies that you know that your client of your library is going to need, you can re-export them, but they might not always need them, so you can have it on a feature toggle. You can also use it for the vendoring of C libraries, for example, OpenSSL sys. So this idea of vendoring of C libraries means instead of using the one that's on the machine, you would enable having it built with a vendored copy. You can also use it for things like proc macro companion packages. So in the example earlier, we had derive was one of the features, and it gives you a load of proc macros that allow you to automatically derive implementations of serialize and deserialize on your structs. But you might not necessarily want that. But if you do want it, it's much easier to be able to enable it with a feature toggle, with a feature flag, rather than have to pull in an additional dependency. So I'd really recommend, if you want to see more examples of different features, the cargo reference, you'll see I put links to the cargo reference doc in various pages through the slides. It's a really nice companion to the book, I would say, is having the cargo doc and the Rust documentation kind of open side by side to compare how they're assessing different topics. If you're authoring a crate, then as mentioned, you can use these flags to enable functionality. What that actually looks like in practice is you have this features section, features key, and in this case, we're defining a feature named WebP, and that feature doesn't do anything else. It's just that particular feature. And then if someone has enabled that feature, then that means that the code that is underneath this config feature equals WebP will be compiled. If the feature is not enabled, then that code beneath it won't be compiled. It won't be included at all. You can also use features to enable other features. So there might be a few features that commonly go together. So in this case, it's got iCode to enable bitmap and PNG. And if you set the features equals ICO, then that will enable both BMP and PNG. But you could also have enabled them just one or just the other separately. And you can also introduce a set of default features. So if you know that a crate is going to almost always need this particular set of features and you don't want to force people to have to opt into them every time, then you can set up default features. But by having them as features, it means if you're in an environment where, you really want to keep everything minimal, you really want your compilation sounds really small, but you're not going to need some of those default features, then you can opt out. And yeah, this is how you would opt out. So you set the default features equals false, and then you can choose to optionally enable some other features. So in this case, we've turned off the default features of Flake2, but we have turned on specifically the zlib feature. There's also these kind of feature flags for binary crates. If you're running it, you would use -- no default features. Or actually, even when you're doing it for lib crates, you could do that. You can also use features to enable other dependencies. So, for example, maybe when you've enabled certain functionality, you need an additional dependency that you didn't need before. So you don't want to pull it in every time. That would be kind of wasteful and unnecessary. So instead, you make that particular dependency, so in this case, GIF, you make it optional. You set optional equals true, and then you can choose to enable that dependency by doing images equals GIF. And what's happening there is that Cargo is making every optional dependency a feature with the same name as that dependency, which can get you into a little bit of trouble. You can get name clashes. So if you have a name collision, then you could avoid it by doing like a rename. So in this case, I've called the dependency GIF_dep, but the package itself is GIF, and then that allows my feature to be called GIF as well. But from 1.60, you can avoid that collision entirely by having this dep : kind of namespacing of that dependency, so that way there's no clash between the feature. Sorry, this light in this room's on a timer, so I have to move regularly. Yeah, so there's no collision now because the dependency has this prefix of dep when it's kind of turned into a feature toggle, which is kind of nice. You can also use this kind of addition, like an enabling of dependencies to enable just specific features. So if you write package name / feature name, then that will enable a dependency feature if the feature's set. So in this case, you've got a parallel feature on your crate. And if you enable the parallel feature, you are going to want the rayon feature of the JPEG decoder dependency. So you're basically kind of cascading features almost, where it's like your feature requires another feature in one of your dependencies, and so on. It does have a slight side effect. So if this JPEG decoder was also optional equals true, just by enabling the JPEG decoder / rayon feature, you're actually also going to include the dependency, which maybe you want, but maybe you don't. So it is something you want to be a little bit careful of. So they introduced this question mark syntax, which means you only enable the feature if the dependency itself was already included, which is a little bit subtle. The example they give in the doc is really, really good for this. In this case, we've got two features, SERDI and color. If we've got color enabled, then that means we're probably going to want the SERDI. So if we've got SERDI enabled and we've got color enabled, then we're probably going to want the SERDI feature of the RGB crate. But if we don't have color enabled, but we do have SERDI enabled, then we don't need to pull in RGB still, because we don't have, if we haven't enabled the color feature, then you don't need the RGB dependency at all. So you wouldn't need the SERDI feature. So it's quite, again, like subtle syntax, but a nice one to know about, because then you kind of understand how you can enable features and only include what you actually need. When you're defining your own features, you really want them to be additive, and this is something that Jon Gjengset really emphasizes in the book. This is something you absolutely really want them to be additive, because crates should not have mutually exclusive features. And by that, it kind of means if you have one feature enabled, that should not prevent you from enabling another feature. They should always be able to be combined together. They shouldn't cause any clashes. And that's because if they didn't work like that, then you could have compilation failures. So the example that's given in the book is you have a crate, and that depends on some other crate C, which has a feature foo. Then you have a crate B, which also depends on crate C, but with a feature bar. If foo and bar can coexist, then this isn't a problem. But if they're mutually exclusive, then if crate A decides to depend on crate B, then it's going to be trying to include both foo and bar. And if they're mutually exclusive, that's going to break compilation. So it's very important that features are not mutually exclusive. You can use this tool that is mentioned in the book to check every combination of crate features to check that they still compile, which is quite a useful thing. If you are someone who's vendoring a library, then you really want to make sure you're not breaking people, and this is one of the things you could introduce into your pipeline to ensure that. So to summarize the features section there, they're really easy to use. You just add them to the cargo.toml, and then you can use config features equals in your code to conditionally enable or disable different bits of functionality. They're pretty flexible, and you can conditionally enable additional dependencies with them, but also features of your dependencies. You do have to be a little bit careful with semantic versioning to make sure that your features aren't changing behavior. And you also have to make sure you don't have mutually exclusive features, because that will get you into trouble if there's ever that kind of multiple dependencies relying on different features. And that's, crucially, because if one dependency that you have, one dependency in your whole dependency tree enables a feature, that means all of your dependencies use it. And I do want to mention one interesting kind of caveat of that, which is if you're managing like multiple crates, and maybe you've included a dependency that has a feature turned on, and you start relying on that feature, but you don't realize that you personally haven't enabled that feature, then your compilation can get broken if they take out that feature. So if they stop using the feature that you were accidentally relying on, then that can break your compilation as well. So it's you also want to make sure that if you're relying on a feature of a crate, that you are the one including it, because otherwise they could potentially stop relying on that feature, might not necessarily think that was a significant change, but it could break your compilation. And that's something that can happen when you're dealing with workspaces as well. So workspaces are another cargo concept which allow you to collect together your packages and manage them together. They share a common cargo lock at the root, and also a common output directory, which can be very handy for not having multiple, output directories can get pretty huge. The build artifacts can be massive. So by sharing one, they can reduce kind of duplication in there and try and share the same resources. They also share package metadata, and the patch, replace, and profile sections in the cargo.toml are only recognized in the root manifest, and they're ignored in the member crates manifest. So that's something you want to be aware of if you're working in a workspace. You might look up something and it says, put this in your cargo.toml, but if it's one of these three things, then that needs to be in your workspace root cargo.toml. In a workspace, you either have a root package or you have a virtual workspace. So if you have a root package, it means that there's some workspace section added to an existing root package, or a virtual workspace means you have a special cargo.toml which defines all the workspace members. So if you have a particular application, it's that's the application that matters, then you might go for the first kind of strategy where everything kind of sits below that one root package. Or if you prefer having everything kind of separated out neatly and just the cargo.toml at the root, then you might go for a virtual workspace, but either are good. And conventionally, you'll see if you look at some of the common dependencies that you might have, that in their workspaces, they often give the names in their workspace to have some common prefix. And that allows you to kind of easily see that they're related, not end up with any kind of weird name clashes. It's just quite a common workflow. And commands like cargo test and cargo check can all be run at the root, which means you can run it across all of your dependencies in your workspace at once. When you have intro workspace dependencies, so I've got maybe my one main crate that I'm building, but then I've got all of these kind of sub crates almost, so side crates that I do want to include. You typically use a relative path for that, but one thing that Jon points out in the book is that if a dependency that you use is relying on a released version of that crate as well, then cargo won't be able to tell they're the same. So if something has a relative path, but it has the same crate name, it is still considered completely distinct of the crates.io version of that dependency. So that's something you might want to be aware of, because someone might be using your crate and they might need to use a version of it, and then they might also need to use one of your dependencies. But if they're pulling them in separately, then they won't be recognized as the same by Cargo. And if you're in that position, then Jon recommends you could use released versions. So if you use a released version, then it means that you're still pointing at crates.io, even though you're sitting a directory over from the dependency you want. You can still point at crates.io, and that might be something that's better to do if people might be relying on that dependency as well. And then you should just use a relative path if you're relying on something that is not yet published, because obviously it's not on crates.io, you can't use it. Next section is on project configuration. This is quite a whistle-stop tour of information, so also feel free to stop at any point if you had any questions or anything that wasn't clear, or you want to discuss any of the topics. So project configurations is talking about your TOML files. This kind of package key defines the package, and you have things like your name, version, authors. You can set the Rust edition that you're using. Got a new Rust edition coming soon, very exciting. You also can set the minimal supported Rust version, description of the package, some link to documentation URL, README if you're not in the classic README path, a homepage, license is very important. If you're going to be publishing anything on crates.io, you need to decide what your licensing is going to be. You can also have a custom license, for example, pointing at a license file. You can specify keywords for the package, categories. You can also say that it's a workspace. You can give a path to the workspace of the package. You can give the path to the package build script if you're not using the default. And you can also set the repository, and there's even, I think, more things than just this, but there's another page. More things like this. So links is one of the things that Jon calls out. That'd be the name of a native library that the package links with, which can be really useful for getting kind of like versioning of native packages as well. You can also, it prevents you having like multiple includes of the same thing, I think. You can also exclude files if you know you don't want them included when you're publishing. And you can also specifically include files, say these are the ones that they want to use. The next one I thought was like particularly useful, this publish one that you can use it to prevent publishing the package, because it's remarkably easy to publish a package. So it's nice to be able to opt out of that behavior and just cover yourself so you don't accidentally publish something that you're not supposed to. You can also add metadata and set a default binary for cargo run if you're at a workspace and you need to know which of your binaries you want to run. And you can also set a dependency resolver to use. In the patch section, which we already said kind of has to be at the workspace level if you're dealing with a workspace, that can be used to override dependencies with other copies of the same dependency. So the syntax here, this like patch.crates.io, is overriding the default crates.io registry for these particular dependencies. So for foo, it's using a GitHub URL, and for bar, it's using a relative path. You can also override Git sources. So if you have somewhere else, you have a dependency, like in this case, you have github.com/example/baz.git, that's one of your dependencies, but you can override that if you need to, like this. And you can point at a specific branch, for example, as well. If you do end up using the patch section, then you do need to be a little bit careful. The major version needs to match on the patch. So if you've got multiple different versions of the crate, then you're going to have to patch those multiple different major versions, which makes sense. You might have looked, if you type in like cargo tree, you can see your list of dependencies. You might sometimes note that you have multiple ones with different versions in, or if you look in your lock file, you'll sometimes have different versions because one dependency might be relying on a previous major version. And Cargo is only going to look at the patch settings, as said in the cargo.toml manifest, at the root of the workspace. So any patch settings and dependencies are going to be ignored. There's also the profile section, which people use quite frequently for performance, changing things for performance, debugging properties, and changing behavior in certain cases. There are 4 built-in profiles, so dev, release, test, and bench. And the settings for each of those can be configured. So for example, in this one, you say, okay, in the dev profile, I want the optimization level to be 1 instead of 0, and I want the overflow checks to be turned off, which might give me a small boost in performance in exchange for safety. Well, kind of safety. That optimization level has these values, so 0 for no optimizations, up to 3 for turning them all on. You can also use S to optimize for binary size, and Z to optimize for binary size, but also turn off loop vectorization. So there might be someone on the call who knows more about when you would do that, but these are the options that you have available. And you can set those on a per crate basis. So for example, if you know that your bottleneck is 30 and you're never going to be debugging into 30, so you don't really mind, and you also don't mind maybe taking the hit on additional compilation time, then you can whack up the optimization level to 3 for specifically the package 30, but you can set everything else at 2. One thing that I hadn't considered, which Jon calls out, is the fact that generic methods or types that are monomorphized will be optimized as per your crate settings, which is, something to think about. So if you've got like a generic type that's getting stamped out for some specific type in your crate, that's where the implementation lives. It lives in your crate, even though the generic function might have lived in a different crate. Your implementation of it, which is essentially, what you're doing when you're using kind of the templates there, is going to be optimized per your crate settings. Interesting thing to think about. You can also set the code gen units. This defaults to 16 for non-incremental builds or 256 for incremental builds. What that does is it controls how many separate parallel units can be used. And that allows caching to be more granular, because if you're kind of recompiling this little block over and over again, that can be cached well. But it means that you're not going to be doing optimizations or as many optimizations across the entire kind of unit that you're compiling, because you've split it up into separate smaller units. You can also enable link term optimization. This allows you to kind of make up for some of those missed optimizations. You can jointly optimize different compilation units. The options for that are false for thin or just local link term optimizations, which basically means it's just local to the crate across its code gen units. If the code gen units is 1 or the optimization level is 0, then you wouldn't get any. You can also set it to true or fat, which attempts to perform optimizations across all the crates within the dependency graph, or thin, which takes less time, but it achieves similar gains by kind of running in parallel. And then off just disables it entirely. You can also set a panic section. That is a global setting for how to handle panic. So again, it's something that is going to affect everything. If any of your dependencies, they will be picking up whatever you have set for the panic. If you set it to unwind, then it's going to unwind the stack upon panic if it can. What that means is that other threads might continue while this unwind traverses up the call stack until main eventually exits. Whereas abort will terminate the process upon a panic, so the program's going to exit immediately. No threads will do any cleanup. It's just going to stop. And sometimes the abort behavior is all you'll get, because if your platform doesn't support unwind, then you can't support unwind. There are even more conditional compilation things to think about. So we've already talked about feature flags. So here we've done, you can say, okay, only enable the lines below if I've got the JSON feature turned on. But there's also operating system options. So you can say, if I am either Windows or Mac, then do this thing. If I'm anything else, do something else. It can also be conditionally compiled based on context. So you'll probably use this a bajillion times. Config test is what you use to annotate your test areas to make sure that they're only compiled when you're running in test config. You can also have additional tool options for like Clippy and Miri. There's also stuff for like architecture, ABI, etc., that you can all conditionally compile based on. And each of those has like it's kind of a configuration predicate, and you can use, so in this second example for operating system options, you see how it says any of Windows or target OS, Mac OS, but it could be all, or it could be not if you want to like negate, so not do it if the feature is there, for example. And all would mean like if you had several feature toggles and you only want to enable something, if all of them are on, then that's what you would use that for. So check out the reference doc on conditional compilation if you want to see more about those. And then on our final big section, the last bit is on versioning. I'm going through quite fast, so we have lots of time for discussion at the end, which is good. When you're versioning, there's a major version, minor version, and a patch number. So major version has to be incremented for changes that break line code. So if you have made a change that is going to require people to change code in order to have their code compile, then that's a major change. If you have just done some feature additions, then everything should be backwards compatible, and that would just be a minor change. And for patch changes, that's just if there's like little bug fixes or anything small, but no real additional features. So nice quote here: all major changes are breaking, but not all breaking changes are major, which is an interesting policy. This is a link that Jon Gjengset puts in the book. It's this RFC talking about API evolution and how you can keep your language moving forward while still maintaining backwards compatibility and kind of trying to do things in like a sensible way. So do give that a read if you're interested. On the topic of versioning, you can set a minimum supported Rust version. And if you are a library maintainer, then you really do want to kind of give people time to update to a newer Rust version. You don't want to force people to update immediately. So crates will often try to compile with any stable release from the past 6 to 12 months. And any new code that gets added in has to compile with the minimum supported Rust version. And if it breaks for some reason and you do need to bump up the minimum supported Rust version, then that could either be considered a minor change or a major change, depending on how you're viewing your semantic versioning. But you typically check that you are respecting your minimum supported version with CI, but it might be nice, Bill mentions that it would be nice to have kind of more cargo support, more native support that would make it a bit easier to check. You can also, and you will also set minimal dependency versions. So in your cargo.toml, you list out the dependencies and the version you want, but you don't have to list out all the way down major, minor, patch. You could just list major, minor. You could just list the major version. But it should be the minimum version that you support. But in this case, it's like, is this the minimum version you support? Maybe, but maybe you would compile with 1.1. Maybe you're not actually relying on any of the new functionality that was added in at 1.2. If you want to maximize compatibility with other crate dependencies, which might have some reason for locking onto an exact version, then you want to consider what is the minimum version that your dependency supports. One thing you could do is, list the earliest version that has everything you depend on, but like, how do you find that out? You've just pulled in a dependency. You haven't necessarily thought super closely about whether that's the oldest version that you could compile with. And one thing you can do is change your dependencies to only specify the major version and then compile with this flag Z minimal version. And then that will tell you if the compilation fails, it means that you do need to specify a minor version for something. So you go through, fix that case, run again, find another one, fix that, and then you would end up with a set of minimal versions that you compile with. And then you could add that into your CI checks. In theory, I can't imagine doing this for just like everyday casual usage, but I guess if you're a library maintainer and your dependency is being used by a lot of people, then this stuff can start to really matter to people. And in the next section, then I think it's the final one, is changelogs. There's a lot of opinions on changelogs throughout different kind of language communities. It's not a unique Rust thing. It's a general thing. Some people generate their changelogs from their Git logs. Some people customize, like handwrite them. Jon recommends this keepachangelog.com as a reference that you can look at to get inspiration for your changelogs. There's a nice quote in it. Don't let your friends dump Git logs into changelogs. So I can see that. It's like your Git log's already there, so why are you dumping it into a changelog? Is it something that's actually human readable? It's got some nice, advice in it that you can take a look at and see if you like it. This is a quote from the website. Changelogs are for humans, not machines. It's a nice way to think about it. If it was for machines, then you could just use the Git history. Ideally, there should be an entry for every version of your software. So in your changelog, it's going to go down the versions. And the same types of changes should be grouped together so it's easy to read, easy to parse with your eyes. And versions and sections should be linkable so that you can jump between stuff and provide links to it in other places. The latest version should come first so that you just see it as soon as you open the page. And the release date of each version should be there. And you should mention whether or not you follow semantic version. I feel like most people do these days. And they give a recommended list of possible groupings. So added for new features, changed for changes in existing functionality, any deprecations, any removed features, any bug fixes, and any security vulnerability fixes. And in particular, like, removed features and soon to be removed features can be really useful to find out, like, when did this change, or change in existing functionality. If you want to go in and say, look, something broke and I just want to have a look at the changelog and see what happened. This, you want good, easy to read at a glance changelogs to find out what happened. In terms of how you bump the version in your code itself, so in your cargo.toml, you specify a version. When should you bump that? And this is something that we've had discussions about on people I work with, and I'm sure lots of people have gone through it. This is one possible workflow, which Jon mentions. There are other ways that people do this, but this is quite a nice one, even if it does require a few maybe extra bumps than you might need if you just waited until the end. So after a release, you can immediately bump the version to the next patch version. So you work on the assumption that your next release is probably going to be a patch release. But if you then, before the next release, find that you have to make a code change that's an additive change, so you're adding a feature, then you go in and you're going to bump it, bump the minor number. Still with this suffix like alpha1 to tell you that it's not actually released yet. And then if there's a breaking change, then you bump the major number. So in this case, we're going from 2.1 to 3.0. And then when you're ready to release, you remove the suffix, you do the release, and the process starts again. You bump the number, ready for the next one, which is quite nice for a few reasons. Like if someone's depending on functionality, then they can see if something's changed. But it does require you to keep track of what's actually happened, what was the last release version. Because like say you did a minor change that meant you had to add bump the minor version, and then later you did another minor change, you have to know what the last released one was to know that you don't need to bump it again. Although actually you should be able to figure that out from the zeros anyway. But yeah, it's a nice workflow to make sure that your versions are always in sync with the code and that you're not accidentally relying on you're not accidentally implying that someone can rely on your code. Like maybe they want to use your latest Git version or a specific Git version in order to pick up a patch fix, for example, that hasn't been released yet. But if you've also made a major change in that, you want them to know that there's a major change so that they can't rely on your main. Oh, it's my light again. So, and yeah, that is the end of the chapter. It had a lot of stuff in it, a lot of kind of disparate bits. It's quite separate to some of the other chapters in the book. That's something that Jon mentioned at the very start of the book. The first two chapters kind of underpin the remaining ones, but the chapters thereafter aren't necessarily linked to each other. So it was quite self-contained. We kind of went through cargo features, workspaces, and project configuration and versioning. There's a lot of stuff. So let's open up to questions, thoughts, how you found the chapter. If there was anything in there that you didn't know that you're like, oh, that's useful, I will remember that. Then feel free to put your hand up or unmute or post in the chat if you don't want to talk out loud. Okay, there's a few comments in the chat. Matt says, config test is only really used for conditionally compiling modules that will only contain test functions. Test functions are marked with test. It is, but then sometimes you use config tests for like if there's like a method that you don't want to put in your module because it has to live somewhere else, but you're only relying on it for tests, then you can use it for that as well. So you sometimes use it for like including other dependencies as well. It's normal. It's almost always used for the modules, but it can be.
You can use it anywhere where you put a config thing, but you usually see it wrap in a mod,
Yeah.
which contains all your unit tests. That's where I normally see it.
And oh yeah, sorry, someone already answered below.
There's one thing I want to add. I wrote it there. Is that there wasn't mentioned? Is that semantic versioning has exceptions when your major version is 0,
Yes.
which means that all rules are off.
Well, not all rules. The rules are different, but they do exist.
Well, you don't have to bump up a major version if you do a break and change. And this is why a lot of people want crates to become version 1.0.
Yeah, everything shifts down a level, like definitely as far as cargo is concerned when it comes to dependency resolution, it will base it on everything being one down. So you cannot mix a 0.2 and a 0.3 because they're considered incompatible.
There is a cargo plugin or few that could analyze your code and figure out what the next version number is. By
outdated, that's one of the ones. And then yeah, cargo updates all the ones in your cargo lock, but cargo outdated tells you if there's something that it can't bump. It's quite a very handy one.
I've never used it, so I can't.
Have used it. I've got a lot of false positives from it sometimes as kind of code base and scale. There's some things where it's like it says that it's outdated, and you're like, it's not really, but I've not dug into figuring out why. It's possible that it's just a user error on my part. Oh yeah, someone says another use of features is to implement some crate trait on foreign types. Yeah, that's a good example. Right. Any questions? Any kind of thoughts? How are people finding the book so far in general? It's a lot. There's a lot in it. It's, okay.
Did you have advice for including crates within a crate in terms of file organization? Is it better? Because I've seen some projects have like a crate subfolder inside next to the source folder, or is it better to have those crates outside as siblings in a workspace or something? Did he give any advice on that? I haven't read the chapter, I'm afraid. So.
He didn't give an opinion, but like definitely sibling crate seems to be the standard. The main advice he gave was, well, not advice, but just convention is that people often prefix it with like the primary crate name or some common name. So like, for example, like Tokyo has its like Tokyo crate, but then it also has Tokyo utils and it also has Tokyo macro. I mean, don't quote me on the names. Also, maybe that's a bad example, but I think that's how it's laid out. And you'll see that with other dependencies. So you can kind of see these are all related, and their names therefore will kind of reflect that and have some common prefix that allows you to tell that they're grouped. Yeah.
Cargo should have name spacing.
Oh, okay. I've got a question. So, since Rust uses LLVM and LLVM is used by C and C++ compilers and TOML is designed as a general purpose configuration file format, is it possible to include C and C++ files in the same TOML file for compilation? So for including, what's kind of the workarounds or best practices for calling compiled C and C++ executables and libraries saved in the same folder? So you definitely can include stuff. It doesn't tend to be in the TOML, although you can put that link key that was mentioned to say this is using this library. But it's a build.rs that does all the heavy lifting. So that allows you to send additional instructions to the compiler to say, okay, this is where my binaries are, this is where my headers are. This is, you can get it to do a lot of stuff in the build.rs. There's some very nice, good documentation on it. But yeah, you can absolutely calling, definitely you can call into libraries and you can link against those using the build.rs. There's crates that will help you do that will make it easier. So the classic one is bindgen, which is very C API vibes. And then there's also, oh my gosh, drawing a blank. Literally mentioned it at the last meeting.
Cbanggen as well, which is the opposite.
Cbanggen.
But
the David Tolnay one that's developed at Meta that allows you to have, that has a lot of common C++ objects as well. So you can work with like vectors and smart pointers, and they've already kind of been pre-wrapped. So you don't have to write necessarily unsafe code to interface between your Rust and your C++, which is quite cool. It's very limited, but often that's all you need is those few containers. So it's quite nice. I haven't actually used it, but I really enjoyed the talk on it at Rust Nation.
I'd like to emphasize something, that the Rust compiler, which includes LLVM, and Cargo are two separate things. You can use the Rust compiler without Cargo. Cargo embraces the project sort of organization, the TOML files, all these kind of downloading of crates and linking them together stuff. But ultimately, Cargo then calls the Rust C compiler, and the Rust compiler stuff doesn't care about this organization, doesn't care about anything. It just does what the command line arguments are fed to it. So you could, in theory, write your own version of a Cargo system and have a completely different way of building Rust programs if you wanted to. It is the Cargo system that implements the build.rs feature, which is usually used for building C code, invoking the C compiler to build C libs, which then get eventually linked in to the rest of your object files created by the Rust compiler.
Yeah, great point. People always think that, it's easy to get conflated between the Rust C and Cargo. And the syntax in the build.rs is also really strange because it's Rust, but it's not. But the way you drive the key instructions that you want to do is all using print line statements, which always feels like so weird. You're like, what am I writing? But seems to work. So
yeah, so Cargo compiles your build.rs, then runs the process, and then takes what's produced in standard output as commands to itself to then do what it has to do. And that's why you got the weird print stuff.
Right. And Vladimir's added, Cargo has built-in functionality for separate subdirectories containing test examples and benches. Yeah. You often see separate directories to handle those like different use cases. So tests would be for your integration tests that are testing the like external API of your crates. And then examples would be, examples. It could contain binaries, could contain a bunch of other crates in it that just show you how to run specific things or do common use cases for your library. And then benches for benchmarks. Benches for benchmarks? Benches for benchmarks. I've not actually used benches, so if anyone else knows anything more about it.
I use examples a lot when I'm doing like a lib-only crate to have a bit of code that actually can run my library. It's really useful for that.
Really nice. All right, if there's no more questions, I mentioned we've got coming up. Oh, sorry.
I was sorry. I was I was going to comment on benches. I've been using them quite a lot. There are a few kind of sub frameworks for organizing for actually computing benchmarks. One common is Criterion, but it's integrated very well with Cargo.
One thing I want to add
in
about
the TOML file, you can specify. I think the the group name for benches is it's either benches or benchmarks.
Do you think you could drop a link in the chat to the tool you mentioned that you use for it? Just
Criterion, yes. It originates from Haskell, actually.
It's a pretty cool tool. I would like to add something about workspaces that wasn't mentioned. The workspace stuff is smart enough that if you call, say, cargo run or cargo build in the root, and there's only one binary member, it will run that. You don't have to say, I want to run this particular binary when you're in the root. And if you use run with examples, it will search through and find. It's pretty good that way. If you have more than one binary, then you're going to have to differentiate and say, I want to run this binary using the -- bin flag.
Mm. Or by adding, if you know that you're going to be running one way more than the others, then you can set it as default run. So in that packages thing, you say the default run is me. I want the default run to be this one.
Good call.
Yeah, there's so much in there. The doc's really good, but it's, yeah, this chapter I thought that I definitely saw new stuff in it that I hadn't heard before and things to kind of play around with. But it's really nice to, yeah, be forced to engage with it a little bit more and read some more of the docs and be like, yeah, you should take advantage of some of these things that are in there. So coming up, we have 2 meetups scheduled. Well, semi-scheduled. The dates might change, but this is currently what we're thinking. 15th of May will be chapter 6, which Tim has kindly agreed to cover, oil and sheep wool, Tim. And 29th of May would be chapter 7 macros. So if anyone wants to cover that chapter, then it is wide open. If not, I will cover it. So it's, the show will go on, but it's really nice to get new speakers in, and you learn a lot from doing a chapter. So it's definitely worth doing. So please drop a message. And as I mentioned, all the chapters after that, so chapter 8's got a speaker. Kavi's kindly agreed to do that one, but we're looking for people to cover follow-on chapters. The 15th of May is also a special one because that's going to be 5 years since the meetup started, way back when in person, which was for Rust's 4th birthday, which means it's Rust's 9th birthday on the 15th of May as well. So it's a nice kind of, yeah, we'll try and see if we can dig up some pictures from the very first meetup that was in person. So for context, newcomers, we were in person, then the pandemic hit, I moved away, and other people kind of moved and other people joined during the pandemic when we were virtually online. And then we kind of just stuck with that because that was the easiest way to interact. Yeah, so we'll try and share some info on the 15th of May about a little bit of the meetup history.
There's another one we've planned, Ciara.
Oh, yes, you tell Alex mentioned, but
So a short while back, I did a talk on Bevy ECS. I want to do a second talk, so I'm going to announce it here, so I kind of commit myself to it, so I don't just sneak away from it. So the second talk I want to do is about the Bevy app crate, which is a partner with the Bevy ECS crate, which does a lot of the foundational stuff for Bevy. So I hope to give that talk around mid-July.